So here I have come with another very interesting episodes on the Prism. So already two episodes uploaded. Okay, if you missed, you can see the previous two episodes on Prism. Okay, so where I discussed what is Prism, what is angle of deviation, how you can calculate the angle of deviation, and many more things. Okay, so here it is. Today we will discuss first the total reflecting prism. Okay, the total reflecting prism we will first discuss. Okay, so if you missed my previous episode, I already discussed about the reflection of light and refraction of light. Okay, and many things on the chapter light. Okay, so subscribe my channel and you can see all the episodes over there. And very soon we will upload the episodes on other topics. Okay, so the standard will be from class 6 to class 12, even the JEE main and advanced, and also for the NEET examination. Okay, so let us start the today's topic. First, we will learn today total reflecting prism. So, suppose this is the prism made of glass, okay, and it is right angle isosceles triangle. Okay, the cross sectional area of the prism is right angle isosceles. That means here AB is equal to BC. Okay, the two sides are same. This is 45 degree and this is what 90 degree. That is right angle isosceles triangle. And this is what? This is the hypotenuse. AC is equal to what? AC is equal to hypotenuse. Okay, AC is equal to hypotenuse. So right angle isosceles triangle. So let PQ is the ray. PQ is the ray falling perpendicularly on the surface AB. Okay, and straight it will fall. Okay, it will be refracted straight away, and it will fall on the surface AC at the point R. So if we draw perpendicular on the surface AC, then the angle of incidence will be 45 degree. What do we know? Suppose it's a glass medium, it's a air medium. The critical angle of glass with respect to air is 42 degree. Okay, so the if angle of incidence is greater than 42 degree. Okay, then what will happen? The total internal reflection will take place. So it is not be refracted to the air medium. So as what? It is 45 degree. So 45 degree, what we know? 45 degree is greater than 42 degree. Okay, that means what? That means the angle of incidence here for this point R is greater than its critical angle with respect to air. So that's why the total internal reflection will take place, and the ray straight away will pass through this path. What? RST path, it will move. Okay, straight away to the air medium. Okay, and it will incident perpendicularly, and straight away it will come into the air medium. Okay, so you see, this surface AC, okay, it will just behaving like a plane mirror. Okay, this is angle of incidence, this is angle of reflection. Okay, so this is just like behaving just like a plane mirror. Okay, where the ray is coming on that, and after reflecting it is going like this. Okay, so this surface is just behaving like a plane mirror. So this is this prism. This type of prism is known as total reflecting prism. Okay, why? Because this is the isosceles right angle triangle. So this is PQR ray. It will fall on this surface at an angle of 45 degree. Okay, but fall on the surface AB at perpendicularly, and incidence on the surface AC or the hypotenuse of this triangle at an angle of 45 degree. So as the critical angle is 42 degree, so no ray will be refracted. All the rays will be reflected back. Okay, in the path of RST. Now here see, this is the incident ray and this is the emergent ray. So the angle of deviation is delta is equal to what? 90 degree. So here the angle of deviation between the incident ray and the emergent ray is 90 degree. Okay. So due to this prism, the ray is entering to this path and coming out to this path. So what is the angle of deviation? Angle of deviation will be 90 degree. Okay. So this type of prism, total reflecting prism, can be used as a substitution of the plane mirror. Okay, in many optical instruments. Okay, what are the advantages of that? The image will formed by using this total reflecting prism will be much more clear and prominent than compared to the plane mirror. Okay, it will be only one image will be formed, and it will be much more clear and prominent with respect to compared to the plane mirror. And as the plane mirror, there is a layer of the mercury at the back. So if the layer of the mercury is not properly done, then also the image will be not so clear. Okay, but here the only one image will be formed and it will be clear and prominent. Okay, so this is the advantage. And what is the disadvantage? It is a little bit costly than the pen mirror. So obviously the cost of the instrument will be high. Okay, so this is the total reflecting prism. Okay, so we can use as a isosceles right angle triangle. Okay, as a total reflecting prism. Okay, where the angle of incidence on the hypotenuse will be 45 degree, where is that is greater than this critical angle 42 degree. So it will be refracted to this path. Total internal reflection will take place, and to this path RST, it will go straight away to the air medium. Okay, so I hope it is now clear. Okay, to you. So moving up, coming to the next topic. Okay, so image erecting prism. What is actually image erecting prism? Okay, image erecting prism means, suppose the object here, the object is inverted. By we want an image, okay, where the image will be erect. Clear? So how we can utilize the prism to make to have an erect image of an inverted object. Okay. So how to create an erect image of an inverted object when the angle of deviation is 0 degree. That means what? No angle of deviation will take place. Okay. So the incident ray and the emergent ray will be on the same line. That means no angle of deviations will take place. Okay, how to do that? So it is also a prism. It is right angle isosceles. So this angle is 90 degree and this is 45 degree. This is 45 degree. So here AB is equal to BC. AB is equal to BC just like before, and AC is what? Is hypotenuse. AC is hypotenuse. Clear? And angle is 90 degree. So now say PQ. PQ is the object. Okay, which is inverted. You can see in the diagram. It is inverted. Okay, it is the top portion of the object. It is inverted. Now the two rays will fall on this surface and it will be refracted. It will be refracted inside the prism, and refracted ray will move towards the perpendicular drawn at this point of incidence. Okay. So as it is a denser medium, so it will move towards the perpendicular and it will strike on the surface BC at an angle of 45 degree. But what is the critical angle of glass with respect to air is 42 degree. This is theta c, the critical angle. But here the angle of incidence is greater, what? 45 degree. 45 degree is greater than theta c. Okay. So that means what? No ray will come out or refracted in the air medium. So all the ray will be reflected back. This is applicable for this ray also. It will be reflected back inside the prism. Okay. That is total internal reflection will take place as the angle of incidence is greater than its critical angle. So now it will incidence on this surface AC at these 2 points. Okay, suppose this is XY, the 2 points are XY, and from there it will what? It will move away from the perpendicular, and also it will move away from the perpendicular. And P dash Q dash will be the image of the object PQ. So we will get an image which is what? You see, the image is erect. Okay, the object was inverted and the image is erect. And this is the incident ray and these are the emergent ray. The angle of deviation is now 0 degree. Clear? So this is how we can have an image, erect image of any inverted object by using a prism where the angle of deviation is 0 degree. So I think it's clear to you. Okay, so moving to the next topic. Move to the next topic. Okay, so in the previous topic what we have seen, how we can create an erect image of any inverted object when the angle of deviation is 0 degree. Now here the same thing. Okay, we will create an erect image, okay, of an inverted object. Okay, so when the angle of deviation is 180 degree. So this is also a right angle isosceles triangle. Okay, so this angle is 90 degree. So here what? AB is equal to AC and BC is equal to what? Hypotenuse. BC is equal to hypotenuse. Okay. So see the ray first. What? This is the ray QP is the inverted object. QP is the inverted object. So this is the straight away it will fall on this, straight away it will fall on this surface AB. Okay. This angle will be what? 45 degree and this angle is also 45 degree. So what do we know? The critical angle of glass with respect to air is 42 degree. Okay. So here what? 45 degree will be greater than the critical angle theta c. Okay, which is 42 degree. Okay. Now what will happen? That's why the total internal reflection will take place. From this surface, the total internal reflection will take place. Now here also, this is what? This is the angle of incidence. It is 45 degree, which is greater than its critical angle again. Then again it will be total internal reflection will take place at this surface. Again, at this surface, total internal reflection take place. So total internal reflection to take place in two times. Here this surface as well as on this surface. These two equal sides. Okay, here one time total internal reflection take place and will fall on this. Again, second time total internal reflection take place and will come in this path. See, so this is the P dash and Q dash will be the direct image of this object PQ. Here angle of deviation will be what? In the same line it is coming. So the ray is entering, incident ray, and at the below it is coming out. So here the angle of deviation will be 180 degree. In the previous case it was 0 degree, and here the angle of incidence will be, angle of deviation will be 180 degree. Here, so here two times the total internal reflection takes place inside the prism, and on the same surface the hypotenuse BC, through this the rays are entering, and from the same surface the rays are again, imagined rays are again coming out. So here the angle of deviation will be 180 degree. So to next move to the next topic. Okay, so next, coming to the next topic, prism periscope. What is a periscope? You all know that a periscope is an instrument through which it can be used to see something in a crowded place, okay, or inside the submarine it can be used to see what is there above the sea, okay. So that means what? The jet-shaped instrument, okay, where one end will keep our eyes and the other end will be above the water or in a place, okay, in a crowded localities of place where we can see any matches or any light things, okay. So this is what prism. So basically we know that the plane mirror are used, okay, for two time reflection, okay, the mirror 1 and mirror 2. So two time reflection will take place, okay, and final that is reflected will fall on the eyes, okay. So we see the image inside the mirror, and as the two time reflection in case of the plane mirror, if you use two time reflection will take place, so that's why no partial changes will be there, okay. That means the object will be seen as it is, okay. If one time reflection takes place, then in case of the plane mirror, the change of sides will be there, clear. But as two mirrors are used, two time reflection will take place, that's why no partial changes will be there. But if we want to see the image more prominently, okay, so we can use the prism instead of the plane mirror. We already seen that, so that we can use the reflecting surface, that means the hypotenuse as a reflecting surface like the plane mirror. We have seen that, okay. So this property we can use, okay. Here this is the hypotenuse of two isosceles right angle prisms are used, where the hypotenuse will be parallel to each other. This is hypotenuse of this prism, suppose A, B, C, and this is what? This is the hypotenuse of this prism, okay. Suppose A dash, B dash and C dash, okay. So BC and B dash, C dash are the hypotenuse, okay. So the rays will fall on this straight away, the parallel rays, okay, on the hypotenuse, and it is what? This is the internal reflection will take place because it is 45 degree. The angle of incidence on this surface, so it will straight away, it will come like this, and for this point also it is come like this, clear. And this angle of incidence is also 45 degree for this prism, and so total internal reflection will take place, and it will move straight away, it will come out from this prism, and this ray when it will enter our eye, we can see the object here, okay. So this prism where the images will be more prominent, clear, and it is more efficient than the normal periscope where the plane mirror is used, clear. So students, so today up to this, okay, now I am coming with some numeric problems, okay, of the prism, on the prism actually, okay. So let us solve that, okay, then we will move to the next chapter.